Hi everyone, for today we're going to talk about distance versus displacement. So this has to do with motion. To start, let's have a warm-up. In car races like the Indianapolis 500, drivers often travel 500 miles or more, but their final displacement is only a few feet. Why? So as we go along with our lesson for today, we will figure this out because our objective for today is for us to be able to understand frame of reference and describe differences between distance and displacement. For us to understand the concept better, it is important for us to know first what is movement. In order to study how something moves, we have to know where it is in relation to something else, and this location is an object's position. To visualize position for objects moving in a straight line, you can imagine the object is on a number line. It can be placed at any point on the number line in the positive or the negative numbers. It is common to choose the original position of the object to be on the zero mark. In making the zero mark the reference point, you have chosen a frame of reference. So basically, when there is a starting point or a reference point, frame of reference is present, and you can use that to measure distance or displacement. Distance versus displacement. When an object moves, we often refer to the amount it moves as the distance. Distance does not need a reference point and does not need a direction. If a car moves 50 kilometers, the distance traveled is 50 kilometers regardless of the starting point or the direction of movement. Distance is a scalar quantity because it does not have direction. So to solve for distance, you just need to add the total distance covered by the object or a person. If we want to find the final position of the car, however, just having the distance traveled doesn't allow us to determine the final position. We need to know the starting point and the direction of the motion. The change in the position of the object is called its displacement, and displacement is change in position, which is final position or x2 minus original position or x1. So that is the formula that you will use. Triangle D, or change in displacement, equals x2 minus x1. For example, on the below diagram, you see there a person walking from point A to point B. Point A is the starting point or the original position, and point B is the final position. You just have to subtract final position with the initial position. So if final position is 5 meters, you will subtract it with 0 meters, which is your initial position. Therefore, your displacement is 5 meters going to the right. Take note that if the person or object will go back to its starting point, the displacement will become 0, because going to the right it's 5 meters, and then going to the left is 5 meters. 5 minus 5 equals 0. The displacement must include a direction because it is a vector quantity. It could be positive or negative direction, east, west, north, south, or left or right. Let us go back to our warm-up earlier. The cars travel a distance of 500 miles over the course of the race. However, they are traveling in a circle and the start and finish line are the same. So what would be its displacement? When the car finishes the race, it is essentially the same position it was when it started. Therefore, the car's total displacement is only a few feet, or if it is exactly in the same spot as the starting point, then the displacement is 0. But for the distance, you can solve for it, and it's 500 miles. To summarize, the length traveled by an object moving in any direction or even changing direction is called distance. The location of an object in a frame of reference is called position. For straight line motions, positions can be shown using a number line, and the separation between the original and final position is called displacement. The resource for this lesson is www.ck12.org. Thank you for watching and see you next time. Have a great day.